Good morning, students. Myself, Vijay Shankar from ECE Department, Chippewa Engineering College. Today, we are going to discuss about the magnetic field intensity due to the infinite line charge. In the last class, we discussed about the magnetic field intensity in line charge, magnetic field intensity in surface charge, magnetic field intensity in volume charge by using the Biot-Savart's law. Okay. Now you go for the another topic, the magnetic field intensity due to the infinite line charge. Magnetic field intensity due to the infinite line charge. See the magnetic field intensity H bar due to the infinite line charge is a long straight conductor. Is a z-axis we can assume. On that z-axis, a small differential length we can assume. A small differential length dl bar. That is a 0.1. And on the y-axis, assume a point P with a distance of r, and it is in the direction of AR bar, where you have to find out the magnetic field intensity H bar is a point, and you have to find the magnetic field intensity in this direction H bar, or it is a B bar also, magnetic flux density. And the point 1 from the origin, the distance is z. It is along the z-axis. It is a z into az bar. We have the two components to find the distance of r bar also. Z into az bar is a positive direction. R into ar bar is also the positive direction. Because it is a long straight conductor, the current passes through this conductor. A magnetic field is surrounding the current carrying conductor. Is a current I is also close, so it is a I into dl bar. The point what we are assuming dl bar, because it is a conductor carrying the current I dl bar is at the point 1, and you have to find the direction is AR12 bar. You know the H bar is equal to, due to the line charge, I into dl bar dash AR bar by 4 pi into R bar. Okay, and this becomes of the K into AR bar, or not the K into K bar cross AR bar into ds, and it's j bar cross AR bar into dv in the numerator multiplied. It is into dv is a surface integral h bar, and the h bar is equal to the volume integral. This is a volume integral, and this one is a surface integral, and this one is for the line integral. So we are assuming consider an infinite line straight conductor along the z-axis. The current is passing through the conductor. Is a direct current of I. The field intensity H bar at a point P is to be calculated, which is at a distance of r from the z-axis. Consider a small differential element dl bar at point 1 along the z-axis. At the distance z from the origin, I dl bar is equal to because it is on the z-axis. dl bar is a small differential z dz along the z-axis. So I dz az bar differential length DL bar is equal to, it is on the Z axis, so the dz into az bar. Got it, my students? So assume a right angle triangle like this. With here the point P, here the point P is there. To find the magnetic field intensity at the point P, you get the downward direction of Z into az bar and the positive y direction, nothing but is a PR bar. So minus Z az bar and the R into AR bar, and towards that is a point Q. So R12 bar is equal to the components, the two components are minus Z into az bar plus R into AR bar. And the base vector A R12 bar is R12 bar by the magnitude of R12. So magnitude is under root of the AZ coefficient and AR coefficient. R square plus Z square. And R into AR bar minus Z into AZ. Now in the numerator, to find the magnetic field intensity, we need the DL bar cross AR bar. So the H bar is equal to, the line integral, H bar is equal to, I told that it is I into DL bar cross AR bar. And similarly for the surface, I told that is a K bar cross AR bar. Volume integral is a J bar cross AR bar. So totally the numerator. So here it is a line integral because we are assuming a long straight conductor on the Z axis. So DL bar cross AR bar. DL bar cross AR bar. So we considered here it is a cylindrical coordinate system. AR, A5 and AZ bar. What is a DL? DL bar is equal to, see here, DL bar is equal to dz into az bar. What is the remaining r and the phi is a zeros. So r is a 0 and the phi is also the 0 and dz. DL bar is equal. And AR bar is equal to the base vector AR bar is equal to, see here, the two components are there. One is AR bar component and another one is AZ bar component. And there is no A5 component in the AR12 bar. Okay. So here AR bar, the R component, there is no any A5 component if it is a 0 here. And AZ bar, the coefficient is a minus Z, you can take the Z. Okay. Any function AR bar cross B bar is there, you can find the dead function. And denominator A square plus under root of R square plus Z square is also there. I am finding only the DL bar cross AR bar without keeping the under root of R square plus Z square. Now see, to find the debt of this function, AR bar, and you can find both are the zeros only. And you take this line, the 0 into Z bar and dz into 0 is the 0. Then take the A5 also, A5. The 0 into Z bar, it's a 0. And here the dz into R is a minus actually. For the second term also, you can take the minus. Okay, minus into minus is a plus. So A5 into R into dz. Similarly, the AZ bar is also all the terms is a 0. So what it matters? So DL bar cross AR bar is equal to R into dz A5 bar. R into dz A5 bar. While applying the cross product, the magnitude of R1 bar is neglected for convenience and must be considered the first of further calculations. The magnitude, see here the magnitude is there, under root of R square plus Z square is also there. To obtain the cross product, we are neglecting for our convenience and must be considered for the calculations. The next values, you have to substitute this one. I DL bar cross AR bar is equal to I is multiplied here, I R dz A5 bar, and the denominator there is a R square plus Z square is there. R square plus Z square. Got it, madam? Now the dh bar is equal to, according to the Biot's law, dh bar at the point 2 means the point is on the y-axis. Okay, I dl bar cross er bar by 4 pi r square. What is IDL bar cross er bar? We got IR dz IR dz A5 bar and under root of r square plus z square is there. And what is the R12? R12, we got the magnitude of R12. The magnitude of R12 is under root of the z square plus r square. Okay, so under root of r square plus z square and whole power whole square is 4 pi. Okay, and this is only the function of IDL bar cross AR bar, and 4 pi the R12 is under root of r square plus z square, and square term is there, you can keep the square. So IR dz A5 bar whole divided by 4 pi, and these two functions, the two to get cancelled. R square plus z square whole power 1 by 2 and r square plus z square whole power 1. So 1 by 2 plus 1. Bases are same, you can add the power. That is it, 3 pi. Okay, IR dz A5 whole divided by the 4 pi r square plus z square whole power 3 pi. Got it, my students? And here, when you take the integral on both sides, h bar is equal to the integral of because it is with respect to the z is there. Z is equal to varies from minus infinite to infinite. Z is equal to minus infinite to infinite. IR dz A5 bar by 4 pi into r square plus z square whole power 3 pi. Okay, from this right angle triangle, suppose you have the right angle triangle, we can assume the theta is there. Opposite side is the r and adjacent side is the z. When we consider the theta, so tan theta is equal. Opposite side is the z and the r. So here they are assuming the theta is here. The theta, the distance from origin to the point 1 is the z, and the distance from origin to the point 2 is r. So opposite side, the tan theta is equal to. Opposite side is a z, and adjacent side is a r. So z is equal to r tan theta from this right angle triangle. Okay.